Welcome everybody to the CSCA Montreal chapter. Our speaker today is Keith Fox, and he's going to talk about the human genome modification. Should scientists be allowed to change our genes? I'm Joseph Vybihal. I'm your host. I teach in the School of Computer Science at McGill University. Keith Fox is Emeritus Professor of Biochemistry in Southampton University and was Associate Director and then Director of the Faraday Institute for Science and Religion in Cambridge. He studied natural sciences in Cambridge, specializing in biochemistry, where he completed a PhD in the Department of Pharmacology. He moved to Southampton as a lecturer in biochemistry and pharmacology, and then became a professor in 2000. His research interests concern DNA structure and its recognition, and his scientific work has been published in over 200 papers. And I can go on reading, but I won't. I would like to welcome Keith to the Montreal chapter.
Well, as I say, it's really good to be with you this afternoon. I am a biochemist, and a biochemist through and through, with DNA as my speciality. I'm not an ethicist. I have no qualifications formally in theology, although I'm presently studying at a college in London. So I hope I can introduce you to some of the science and some of the issues that are raised, and do that in a way that I hope isn't too technical. This is a subject that affects everybody. The ethicists and the scientists might like to talk about it, but it's the ordinary person in the street who's often going to have to be making some of the decisions. So let's, as Joseph has already said, I've got three logos at the top right of my screen: the University of Southampton, where I worked for nearly 40 years. To the left of that is the Faraday Institute in Cambridge, where I was half-time for 6 years. And then the logo to the left of that is Christians in Science, where I was chairman of that for a while. I'm still involved with that as editor of their journal, Science and Christian Belief. So let's get into the topic. If we're honest, in many ways, life just isn't fair genetically. Some people seem to be born with good genes, we might say, and others seem to have inherent genetic disadvantages. Some are really good athletes, they're musicians, they're intelligent, they're attractive, and some of that may be their upbringing, and some of it may be just the genetic lottery that they happen to have. Those are very highly favored, great people. Others have profound genetic disabilities and disease. It doesn't seem fair, does it? We didn't do anything to deserve one way or the other. It's just what we get passed on from our parents and our grandparents, etc. Wouldn't it be nice if we could find some way to level the playing field, if you like to use that phrase, to give everybody the same advantage? It'd be nice to do that, not by introducing new genes that have never been in humans before. That has a kind of Frankenstein type of scenario, but a way of distributing the human genes better so that each of us get the best combination of the natural genes that are out there rather than just the lottery. I would love to be an athlete. I went running this morning, and partly because I'm getting older, but I've never been very good at it. I just don't have the right genetic profile to be a brilliant athlete. And of course, some of these things are linked to our DNA. DNA doesn't control everything about it, but it does have quite an influence on lots of things. James Watson, one of the co-discoverers of the structure of DNA, said, "We used to think that our fate was in the stars. Now we know in large measure our fate is in our genes." I wonder if that's a little bit of an exaggeration. Lots of our characteristics aren't just our genes. They're made up with the people that we meet with, the things that we eat, the things that we do, that can affect the kind of people that we are. But nonetheless, there are a lot of genetic disorders. The literature says there's between 4,000 and 6,000 genetic disorders, and about 1 in every 25 children is affected by some form of genetic disorder. Some of those are really life-changing from the moment of birth, and there are tragic diseases, some for children that won't live for very long, others that have a sort of disability that lasts throughout the lifetime, and others are only diagnosed at later stages in life, such as, say, Huntington's disease, which is a really debilitating disorder that only usually manifests itself when somebody's in their 30s or 40s. They live apparently normal lives beforehand. And here's a list of some that I've taken, some of which should be familiar. I assume things like cystic fibrosis, sickle cell, thalassemia, Down syndrome. All of those are, well, they're not uncommon genetic conditions. And each of those arises from changes in our DNA. The human genome, that's our complement of the DNA, those repeating letters as we give it A, C, G, and T. They're about 3 billion bases long. And in some of those instances, a change in only one in those 3 billion can have devastating consequences. So hemophilia, for instance, and well, we'll come on to others as we go through, arise from just one change in all those letters in the genome. Now, here's an example. So here's sickle cell anemia, which is particularly prevalent in those of African origin, although it's not restricted to them at all. There are we can think of reasons why that might be. We can talk about that later if you like. And here we have the DNA sequence of a part of the hemoglobin gene, the normal version, and we change one T to an A. And that is sufficient, that one change in 3 billion letters, to cause sickle cell anemia with a slightly different structure of hemoglobin. If we know there's just those simple changes, wouldn't it be nice just to go in and edit it in the same way as we edit any document that we produce with a word processing program, just to cut and paste in a new thing or replace something that's faulty. It'd be nice to have like a pair of molecular scissors, as they're called, to be able to do that cut and paste. And really, until about 10 years ago, that was a bit of a dream. There were very clunky, long-winded methods that sometimes worked, but within the last 10 years, 3 particular technologies have emerged that enable us very precisely to modify the genome. They go under these abbreviations, TALENs or ZFNs, I suppose I should say ZFNs, and the one that's most widely used and easiest to use actually is CRISPR-Cas9. Never mind about what CRISPR stands for. It is a very versatile, easily done technology for being able to take a section of a genome, maybe as small as just one of those letters, and replace it. And it's easily adapted to any particular gene you want. John Parrington wrote a book called Redesigning Life, and scientists are not renowned for hyperbole. But his phrase from that is, every once in a while, a scientific discovery is made whose impact on society is likely to be so immense that even an abundance of superlatives may not do it full justice, and that genome editing looks set to be such a discovery. And as we go through this talk, as we get to the end, I'll leave you to make your mind up as to whether it is that much of a discovery. I think it is. It could have profound effects on our human identity and the way that we treat each other. Some of what I'm going to say over the next 30, 40 minutes or so may sound like science fiction. I'll be thinking of ways in which this technology might be used rather than ways that it has been used, or at the moment we don't quite have the ability to do that. And you may think, well, why are we thinking about things that aren't possible at the moment? And I think that's very important that we do, because the rate at which science progresses is that what seems like science fiction today very quickly becomes tomorrow's science fact. And so often we find ourselves in a position where we're trying to catch up. The science has already advanced, and then we're trying to think through the consequences. So I think it's very important that we think about these things in advance before they happen, so that we have our, if you like, Christian response, our ethical response well worked out. Sometimes this sort of editing has been used for dramatic effects. Here's one that made the papers a few years back. This was a young girl who was in the final stages of leukemia, was not expected to live. And what happened is some of her blood cells were taken out. They were modified by that one of those technologies. And with a variety of very complicated techniques, put back into her, and she went through complete remission. This is treating fully formed human beings. It has been used more recently to treat hemophilia successfully, and thalassemia and sickle cell disease, and a number of other ones as well, where it's able to replace that defective gene and salvage the good one, and have dramatic effects on people's lives. This is treating, if you like, fully developed humans, for which the ethical questions, well, there are ethics there. There's questions of risk, particularly as to what if it all goes wrong. But where the things start to get very complicated and much more ethically profound is, rather than modifying the cells in a fully formed human, that's called somatic cells on the screen there. It only occurs in then that those somatic cells, if you like, the body cells, they only affect that one individual. They can't be carried on to the next generation. So there's no questions about any autonomy of people that come afterwards. But of course, the problem is, if you're doing it to fully formed humans, you've got to deliver to many cells. And of course, there's technical difficulties to get things into a cell of a fully formed human. And in many instances, it's never going to work. For some instances, you can take a few cells out, put them, modify them, and put them back in, and replacing just a few cells is sufficient to overcome the symptoms of the disease. What would be much more profound is modifying germ cells, so sperm and egg, or embryos that's in a very early stage, where it's only actually one or just a few cells that has to be modified. That means that every cell in the body of the person that develops from that will be modified. You only have to deliver it to a few cells, so it's much more efficient. It's done in vitro, so it's not the whole person. And it will affect then, because it's every cell in the body is modified, it will be in the germ cells that are generated in that person, and therefore will be propagated to the next generation. Of course, if we're going to do that, it means that we're taking an embryo at a very early stage, maybe at the 1, 2, 4 cell stage, and modifying it with this technology. Of course, then you have to test to find out which embryos have been successfully modified, and there are various ways of doing that, of taking a cell out of the 8-cell early embryo, testing that to see if it has been modified. If it has successfully, and you assume that it hasn't been there haven't been off-site modifications where you didn't want them, then you would then implant that, and that you would hope that the organism, that the fetus would grow and come into an ordinary human being. It does, of course, raise questions about the status of the early human embryo. The technique is fairly inefficient. So what you do about those embryos that haven't been modified or have been unsuccessfully modified in the wrong place, presumably they should be discarded. So those who have ethical questions about any manipulation of embryos, who maybe disagree with in vitro fertilization, for instance, or any form of genetic testing, will of course be against naturally any modification of human embryos. The first time it was done was back in 2015 when they engineered human embryos in a way that could never lead to the development of a fetus. They actually used what are called tripronuclear zygotes. In other words, they'd actually been fertilized by two sperm and therefore would have no possibility of developing. There were obviously ethical questions about publishing this work. It's published in, I don't want to run the journal down, but it's a rather unusual journal for publishing what would be groundbreaking research. And the word on the street is that many of the mainstream journals wouldn't take the risk of publishing this sort of work. It was then in 2018 that this Chinese scientist, Jiang Kui, claimed, it has never been published, but he claimed that he'd made the first gene-edited babies. He had modified their genomes in a way that we needn't go into, but it prevented them from contracting HIV. They inactivated one of the receptors for that HIV. It's a natural mutation that does occur in about 1% of the human population. And that he implanted those modified embryos and claimed that twin girls, which were called Lula and Nana, were born. I emphasize, I think that actually did occur. All the evidence is that it probably did, but the results of that have never been published. There was an outcry against all that, not just amongst religious people, but amongst the scientific community. He'd broken just about every ethical rule it was possible. And the Chinese have very good ethical rules themselves. He'd broken the whole lot. And he subsequently went into jail. He is now released. I don't know what he's doing. So it was widely condemned by the scientific community. Why, I wonder? Well, amongst the things that criticize this, is actually it was unnecessary. It wasn't as though there was a therapeutic condition that needed this treatment. There are plenty of other ways of avoiding or treating HIV infection. Most of the criticisms came from that of risk. Had the technology been developed well enough to be sure that they weren't what we call off-target mutations and accidentally modifying something else? I do hope that those two girls that were born are being tested regularly throughout their life to make sure they haven't had any other adverse reactions. He'd actually skipped all the usual ethical approvals. The parents of those children had very limited informed consent. They really didn't know what they were taking on. One gets the impression they were pretty much told it was a form of vaccination. Others will say it's a means of playing God. It's the slippery slope towards some form of transhumanism. And we'll come on to it later as to whether this might be a form of eugenics and making humans commodities rather than persons. I say it is largely science fiction, but I wonder if we did this widely, what it would say about various things that means to be human. What does it say about our attitude to health and disease? I wonder if we're promoting what we might call an ableist mentality of valuing those who are fully fit more than we do those who are diseased. What does it mean about living a fulfilled life, about being dependent on others? The society that we live in says, don't be dependent, stand on your own 2 feet. It's a bit of a shame if you've got to rely on somebody else. But I think, that's not a Christian perspective, is that we look after, we are dependent on each other. Actually, all of us come into this world totally dependent on our parents. And most of us are dependent on somebody for the last few years of our life as well. What does it say about people who suffer from any form of disability? What does it say about people who don't match what we might call our own social norms? And I'll say a little bit more about that later. And ask questions about what we actually value in other people. Francis Collins, who at the time was director of the National Institutes of Health, wrote on the NIH's behalf, saying the strong arguments against engaging in the activity remain. They include the serious and unquantifiable safety issues, ethical issues presented by altering the germline in a way that affects the next generation without their consent, and a lack of current compelling medical applications. So there was an outcry against it. On the other hand, there are those who don't like bioethicists. Here is Steven Pinker, who some of you may be familiar with, writing in the Boston Globe in 2015, who says the best thing that bioethicists can do is to get out of the way. Leave us alone. Let science take its course and we'll see what happens. Don't come to us talking about things like dignity or sacredness or justice. Let science, let it have free rein and we'll see what happens. I hope that you're not happy with that statement from Steven Pinker. However, we shouldn't write it off too readily. And there are theologians who don't describe this as really playing God, because actually we play God in lots of other ways when we decide what we want to do, when we put ourselves in charge of our health, our time and our resources. And is this just another technology for helping us, for reducing suffering? Maybe there is some form of redemption in it. We nonetheless have to say that a Christian duty is to look after the vulnerable and the disadvantaged, not to stigmatize them. And that throughout the ages has been a task that Christians have committed themselves to in health and education. And I wonder, just throw the question out, is this part of the God-given arsenal of techniques that might be used for alleviating human suffering? It's very easy to jump to quick conclusions and say, well, this is sort of scary, isn't it? It's like playing God, and we shouldn't do it. But let me refer you to what Jesus said when the Pharisees criticized him for healing on the Sabbath. He said, and recorded in Mark's Gospel, is it lawful to do good or to do harm on the Sabbath, to save life or to kill? Now, I'm not taking that as a license to do what we want, but we should be taking those words. Is it lawful to do good or to do harm? What should we be doing with that? And obviously, we shouldn't accept disease just in a sort of fatalistic way and assuming that, well, everything's God's will, isn't it? If we'd taken that, we wouldn't have antibiotics, we wouldn't be treating cancer, we wouldn't have all the medicines that we regularly use. So we should be advocates of being able to overcome a disease. But is this a way to do it? As I said, healing, restoration, feeding of the poor are part of a Christian's duties. Is this just another part of it? We are used these days to organ transplants, heart transplants, liver transplants, etc., etc. Almost any organ can be transplanted. I wonder, is this nothing more than just a DNA transplant, giving somebody DNA that they didn't naturally possess? I don't think it is. I think it is much more than that, because we're affecting, I think, some parts of maybe the person's personality. I think we all need to take a step back at the moment, in many instances, ask, is it necessary? And in many cases, it isn't. There's pre-implantation genetic diagnosis at the 8 cell stage, followed by implantation of only the healthy embryos, those that have been selected that don't have the known mutation. It means that most of these modifications are unnecessary. There are 1 or 2 instances in which there never would be any healthy embryos to implant. And in that case, obviously, genetic modification of this sort will be very helpful. But they are few and far between. Let's assume for the moment that we say that in principle, genetic modifications of embryos might be possible. But where do we stop? Should we modify the genome of an embryo that will otherwise die of a genetic disease? And I think that I would argue, yes, that does seem to be giving life where otherwise there wouldn't have been. Should we modify the genome of an embryo that will have, say, cystic fibrosis? No, the child will live. There will be disruptions to normal lifestyle. There may be, although cystic fibrosis patients are living longer and longer, nonetheless, they have a reduced life expectancy. What about the genome of an embryo that will develop a disease that manifests later in life, such as Huntington's disease? Or we know that some of the breast cancer genes give an increased likelihood of breast cancer. Somebody living healthily for 30 years, should we modify that if we see it might be there in embryo? And of course, at the other extreme, should we modify the genome of an embryo for cosmetic reasons? for making them look prettier, or to change their eye color, or even for gender selection. Modifying harmful genetic mutations seems like a good outcome, but we do need to ask questions about what are the risks, and that seems to be highest up in the ethical questions from scientists. What about the consent? The embryo gives no consent to having it being modified. On the other hand, children don't give consent that they're born, and their parents have lots of influences over their lives, especially in the early years when they didn't give consent to that. We need to ask questions about what it says to our attitudes to those who've not been corrected, and ask really, what is normal? And is there a clear difference between therapy and enhancement? And say, is this the slippery slope to enhancement? Let me give you an example that made the news in the UK a few years ago. Deafness in one form is genetically inherited with a known mutation. And some deaf activists insist that they don't have a disability at all. Deafness for them isn't a disability, it's a culture. And so there were two parents who had the gene that made them deaf. And they asked if they could, the scientists, the medics could select so that their child would be deaf, and that would therefore grow up in a deaf culture as a deaf person. I wonder what you would say to that ethical question. The lawyers in that stage eventually said no, that you cannot select for what they would call a disadvantage. But remember that what seems like a disease and a weakness to some seems like a strength and a natural ability to others. And to turn you back to scripture, the Apostle Paul talked about his thorn in the flesh and God's power being made perfect in weakness. Maybe we have wrong ideas about what is normal and what is perfect and what is acceptable. Yeah, here's another example, which I found quite moving when I read it, published in the journal Nature, with a girl called Ruthie who had a genetic mutation that made she had a form of albinism, meant she had very limited eyesight. And they interviewed her parents and they interviewed her and asked the parents, if you'd known before she was born, if she was going to be visually so badly impaired, would you have had her genetic modified? And the answer was, well, obviously, yes. But then they said, knowing the girl that you have now, do you wish that she had been modified? And the answer was no. It would have made her different in a way that would have regretted, they said. And they asked Ruthie as well, did she wish that she had had her genes edited, or edited now so that her future children wouldn't possess that mutation? And she said no. So that becomes part of our character. And in the UK, somebody called Tom Shakespeare is a professor in the London School of Hygiene and Tropical Medicine, is an advocate for disabled people. And he rightly says people with disabilities aren't queuing up for genetic modification. Their priority is to combat discrimination and prejudice. As he puts it, the voices of people living with illness and impairment need to be heard. Nothing about us without us is one of his catchphrases. So how does society include people whose impairments won't be edited away? And in some ways, by reinforcing this genome modification idea, we're establishing what we call an ableist mentality. It assumes independence and physical functioning should be maximized, and any weakness or dependency, any what we might call defect, are inherently bad. What about modifying people's characters? We know that our genes can affect our emotions. Neurotransmitters like noradrenaline and dopamine can affect some of our, if you like, our moods. They can affect our risk-taking. What if we could modify people's genes to make them better people? And this is a project proposed back in 2009, so before gene editing really became feasible. And I take a quote from this, and the italics in this are mine, but it says, nearly all personality traits show some moderate heritability. Since genes influence enduring behaviors, it might be possible to use biotechnology in a manner that would promote virtue and thus serve as a means to improve ourselves, morally speaking. Well, I find that awful. The thought that I should have to behave because I've been genetically modified to make sure I was good, rather than choosing to behave, I find that morally repugnant. We need to be realistic too. For many things, including our characters, there's not a single gene for. There are many genes that interact together to have a combined effect. There clearly is a genetic effect on IQ, but each gene has such a tiny effect, and it's the combination of all those genes together that lead to our individual intelligence. Many genes affect it, and actually so many that on the whole, the best way to deal with it is to get a good education rather to modify any genes. And similarly, other conditions, diabetes, height, there are many, many genes that work together to have the phenotypic effect. So there are limitations to what genome editing can achieve. Genes are very, very important. They limit sometimes they enable us to do things, but they don't control everything about us. Lots of other factors affect who we are, the people that we interact with, the things that we read, the things that we eat, the stresses that we're under. Each of those affect who we are. And in some ways, if we go down a line of what we might call genetic determinism, it leads to a rather distorted society. Because if we think that our human nature is solely affected by our genes, then there's no point in changing society. What we need to do is change our genes. The problem doesn't lie in social structures, but in the individuals who make up society. And the solution is therefore to change, or maybe even to eliminate, the individuals that challenge us and that don't fit into our structures. And that's what happened, particularly with the Holocaust. Those who didn't fit with the so-called social norms were eliminated. So don't edit the human germline, said the article in Nature. It's the slippery slope do we want to edit so that children can have high IQs? They won't go grey-haired like me or white-haired. They might have perfect hearing. They might be brilliant athletes, wonderful musicians, very beautiful. Do we want to go down that slippery slope? This sort of enhancement, and I emphasize it's not a way of introducing new genes, but simply shuffling the pack to make sure you get the optimum, the best mixture of genes. What is enhancement and what is therapy? Is there a clear distinction between them? Well, there probably isn't. The World Health Organization defines health as being a state of complete physical, mental, and social well-being, and not merely the absence of disease or infirmity. I wonder how many of us would actually meet those full criteria of complete physical, mental, and social well-being. And we have other forms of enhancement as well, don't we? We have nutritional enhancement. You choose what diets you should have. And we have pharmacological enhancements where we take drugs. Excuse me. But should we think about leveling the playing field? After all parents wish the best for their children, don't they? They used to say that maybe parents would hope that their child might grow up to be prime minister. Granted, the way in which several of our UK prime ministers have behaved recently, I don't think that should be in many parents' aspirations. But what about maybe parents can upgrade the athletic prowess of their children so as to give them the best opportunity so that their child won't be left behind. As I say, it's shuffling the pack. It's not giving new genes. It's just giving them the best combination of natural genes. That's what parents hope for, isn't it? And they're only just wishing the best. There's a science fiction book by Peter James called Perfect People. It's a totally secular book, but it's a sort of book that I think you read on a transatlantic flight, which the subtitle of that is "Be careful what you wish for." The ending of that quite shocked me. Actually, I wasn't expecting it, and it raises questions: what is normal? Diversity and differences of the way that we do things is what makes society. And actually, we say that people are musically gifted, they're athletically gifted. And we say that's actually a gift that these people have. And life itself is a gift. And we acknowledge that there is, if you like, a contingent factor when we talk about somebody being a brilliant musician. It's not that they're a better person, but somehow they're gifted in that way. So somebody said excellence consists at least partly in the display of natural talents and gifts that are no doing of the athlete who possesses them. After all, human life is a gift, not an achievement. It's what you do with the genetic profile that you've got that matters much more than the genes themselves. And I wonder if this form of selection, it could be taken as being a form of eugenics. So we're manipulating genes so as to reinforce what we think a society should look like. Nothing new in that. Eugenics, in a very brutal way, has been part of humankind for millennia. The Roman law of the 12 states a father shall immediately put to death a son who is a monster, who has a form different from that of the human race. Infanticide was common in Roman society. And it was actually the advent of Christianity that marked a turning point in people's appreciation of life as having intrinsic value and put an end to those sorts of infanticide. Eugenics became popular in the 19th century, particularly in the US. And the argument would go was we spend a lot of effort making sure that we breed the right animals. But with the human race, we leave it to chance and to think mystical things like love and falling in love. And so here's a copy of a pamphlet. How long are we Americans to be so careful for the pedigree of our pigs and chickens and cattle, and then leave ancestry of our children to chance or to blind sentiment? And the whole idea that we should stop, if you like, stupid people, poor people, those they're defined as being mentally insane or feeble-minded or drunkards, they should be stopped from breeding. There's bad science in this. In fact, there's non-science, which is a close ally to nonsense, that each of those states was genetically determined. Pauperism, criminality, feeble-mindedness, they're not genetically determined, and yet there were cases of enforced sterilization of those so as to stop them breeding. But I wonder if we're in danger of sidelining people who don't fit our preconceived personal ideas or views. The fact that we then choose eugenics, what might be called consumer eugenics, as we choose to alter our genes, it's a form of social engineering and a form of reinforcing what is socially acceptable. Let me give you an example where social pressures change things. How do we perceive what is beautiful? And the cosmetics industry and the surgeries that are used to make people, so say, more beautiful. There's nothing inherently written down that says this is a beautiful person. It's what we as a society perceive and have defined as being beautiful. And we come the same thing with if we try to change genes. Here's Francis Collins writing again, effectively saying that we're changing the interaction between parents and children. Children then become commodities rather than precious gifts. And that relationship between the parent and child will be very different if the embryo has been modified to give them athletic prowess, and yet the child then chooses to be a couch potato. Those athletic genes are going to be of no use, no consequence at all. And the expectation of the parents, well, I paid all that money to have you modified, and there you are doing nothing with it. You can imagine that. Imagine in your teenage years, if you discovered that your parents had had your genome modified. It's the sort of, you can imagine the stroppy, you did what to me? You changed my genes? How dare you? And we're in danger then of breeding humans for their mathematical, their musical or athletic ability. And as I say, what if you had been modified or your children had been? And to maybe use some biblical language, it changes the parent relationship, child relationship from one of begetting, a personal, non-manipulative relationship, mystery, and in what the child's future would be, contrasted with making, a technological advancement, making children who happen to match what we think they should be. And it's putting the parents' ambitions into the child. Science fiction, I think we would come up with a form of genetic one-upmanship. When should you have children if they were going to have them genetically modified? Because the danger is that today's genetic modifications will be outdated by tomorrow. So we'll have life 2.0, and then in a few years' time, all the genetic modifications possibly different. And life 3.0 becomes available. It's like the way in which you might upgrade your car or your computer or your mobile phone. Today's enhanced child may seem yesterday's child in only a matter of years. But it isn't a great leap from you can have a genetically improved baby to you must have a genetically improved baby. If a child is going to be born with a genetic disability, there's going to be a cost in that to society. And there will therefore be economic pressures to say, well, it's your duty to have the child genetically modified, to make sure that it's not a drain on society's resources. And here's Arthur Caplan, who I think is a philosopher, writes, renegade scientists and totalitarian loonies are not the folks most likely to abuse genetic engineering. You and I are. Not because we're bad, but because we want to do good. Parents understandably want to give their kids every advantage. And the most likely way for eugenics to enter into our lives is through the front door as nervous parents, awash in advertising, marketing and hype, struggle to ensure that their little bundle of joy is not left behind. I think there's a lot of truth in those statements. And we end up dividing society into what we call the gene rich or the gene poor. And of course, the gene rich will be those who are economically, financially rich as well, because this is going to be a very, very expensive technology. So that it'll be a further way of enhancing the differences across society. I think we need to ask questions too about what it means to be human and it means to be a fulfilled human, because actually faster, brighter and stronger doesn't necessarily mean better. As Stephen Locke, writing in the British Medical Journal, put it, many researchers think that a high IQ goes hand in hand with high moral values. And this correlation is, of course, absolute nonsense. Better people are not necessarily those with high IQ or high athletic ability or whatever it might be. And in the end, we wouldn't have made any better people. We'd have just made enhanced humans. And in a pre-molecular biology age, C.S. Lewis, writing in The Abolition of Man, I think saw some of this where he put it, man's power over nature turns out to be a power exercised by some men over other men. And I'm sorry about the gender specific in that. Some men over other men with nature as its instrument, is we will use our scientific abilities to gain power over each other. What does a Christian say to this? Well, it says that, for a start, we know that we're made in the image of God. Humanity created in the image and likeness of God. But I wonder, what does that mean? I mean, genetically, we're 98% similar to chimpanzees. But that doesn't make chimpanzees 98% in the image of God. There's also nothing sacred, if you like, about the human genome. I've seen some articles written that says we shouldn't modify it because it's sacrosanct. Well, actually, there is no such thing as the human genome. Each person differs from the person next to them by, on average, one change in every 1,000 of those letters. That may not sound a great deal, but if you multiply that up 1 in 1,000, and we've got 3 billion, is that actually means there's 3 million differences between you and the next person. We also know that God is spirit, not flesh and blood, and God is relational, the Trinity, Father, Son, and Holy Spirit interacting with each other. And actually our genetic variation, our genetic limitations are another indication of our human individual uniqueness. Every person is made in the image of God, and every person is different. This is something that concerns the whole person who responds to God. And the image of God is there, unlike in ancient societies where the image of God was supposed to be instilled only in the king or the ruler. The image of God is something that's given to all people, rich or poor, strong or weak, healthy or disabled. All people are part of God's image and are precious in his sight, not just the special ones. Now, we have value because of what we are, not because of what we do. Our relationships with each other, our relationships with God are things that matter. Our mandate, however, is to act as God's representatives and to be responsible and care for creation. That is the way in which I think our role as being made in the image of God is fulfilled. As his representatives, we show what he is like, and we exert his authority over the world in which we live. Adam and Eve are told to subdue the earth. In other words, there was work for them to do well before the fall, to cure diseases and to alleviate suffering. The application of science is one way, I think, that we fulfill that God-given calling. But what does that tell us? Where should we go? Should we act as God's collaborators, but at the same time being careful not to misuse that power, to use it as a means of having power or control over other people and to get our way as to what we think are normal? And the Christian doctrine of sin should make us cautious of the dangers of hubris and arrogance, as I want to get my way and insist that everybody should be like me. There is, of course, in this Zoom call, there is only one normal person, and that's me. All of you are different from me. And I'm sure that each one of you would think that you're the normal person. But we're each of us sinful. We're each of us can be arrogant and lacking in humility. I do think as well, as I sort of draw to a close, it's worth thinking about what if. I sincerely hope that genetic modification of humans' embryos so as to give enhancements don't ever happen. I think there's a good case for genetic modification of embryos to cure debilitating, terrible diseases. But I think, being realistic, it is likely that it will be used to generate enhanced humans, to modify people's athletic abilities, etc. What are we going to do when that happens? It will happen because scientists have egos and they long to be the first to do something. As somebody said, it's better to be wanted for murder than not to be wanted at all. And they will be, their names will be in lights. What are we going to do with those modified humans? And I think we need to decide now that they are not freaks or museum pieces. They are simply enhanced humans. They too will be made in the image of God and they'll have all the usual human responsibilities, privileges, relationships. They'll be fallen people like you or me in need of salvation and redemption. And they too will need to live in society with other people. I want to close with verses from Psalm 139 that may be well known to you. They're written in obviously a pre-scientific age. They're written before anybody had any idea of what an embryo was or a cell was, or certainly not what DNA is. But this is in beautiful language, talking about how wonderful it is to be a human being. And I think it's whether that human being is genetically diseased or not. You create me in my inmost being. You knit me together in my mother's womb. I praise you because I am fearfully and wonderfully made. Your works are wonderful. I know that full well. My frame was not hidden from you when I was made in the secret place, when I was woven together in the depths of the earth. And I think those words are profoundly meaningful for those who are supposedly normal and healthy, and for those who suffer from what we might call disabilities. As I close, let me recommend some things that you might read. Christians in Science have produced a number of very short pamphlets, one on genes and embryos, another one on human enhancement. They're in what they call the Thinking About series. I think there's 20 of them now, various scientific subjects for the, if you like, the person in the pew. And shamelessly, I'll recommend my own book, published along with Alexander Massman, who's a philosopher, on modifying our genes. There's a Faraday paper as well that I wrote, Faraday paper 27. Go to the Faraday Institute website and you can download that for free. Or if you want to buy the book, I recommend buying it from the shop in the Faraday Institute. It's cheaper than buying it from Amazon. So at that point, I think I'll thank you for your attention. Thank you for listening to me. And I hope you've got plenty of questions that will test me and push me, and that we'll talk about some of maybe our ideas and our differences together. So thank you.
That was really very nice talk, Keith.
Keith, you've highlighted well the potential benefits and the potential downfalls. I wonder if there's any international bodies that have produced guidelines, expectations, and so forth around all this, or is everyone just kind of winging it on their own?
Yeah, it's a very good question. Most countries have their own individual guidelines. Certainly in the UK, the Human Embryology and Fertilization Authority, I think that's its abbreviation, have given guidelines on this. I think there's an equivalent in North America. There are others in other places. Some are more strict than others. And I think there was an article published, and maybe it was Science, it could have been Nature a few years ago, that actually highlighted which parts of the globe had the most rigorous restrictions on them. So you could get, if you like, what might be called genetic tourism, where you find the country that has the most liberal view, way in which things can be done. And I'm sure, and that way, a rogue scientist would find it good for their ambitions to go and move to a country where there were no restrictions on these sorts of things. Fortunately, at the moment, the countries with few restrictions are also those that probably don't have the technology. But whereas doing genome modification in the lab on cell lines and bacteria and all those sorts of things and viruses is very easy. It's straightforward. Modifying an embryo in a way that doesn't damage it, that leaves it so that it could then be implanted, requires very precise technology and expensive technology. So I think it's a sort of thing that at the moment, it's only the richer countries that are likely to have labs that can do that. But I think it's a very good question as to whether there should be international rules agreed as to what we should and we shouldn't do.
So in the case of the UK or Europe, to what extent is there a sense of people pushing those rules at the moment? Or is there a sense of collective responsibility? Or there
are those who are pushing on the rules. At the moment in the UK, no modified embryo may be implanted. That is quite clear. And I don't see that changing for some while. Embryos can be modified for research purposes, for use in the laboratory, only with very particular licenses to do so. And there are very few of those that have been granted. And that the modified embryo cannot be allowed to develop beyond 14 days in the laboratory. The 14-day rule is because at that stage within embryo development, that's, if you like, when the primitive streak starts to appear. There is the beginnings of a rudimentary nervous system. And it is seen that that is a boundary that shouldn't be crossed. Now, there are pressures for many scientists to say the 14-day rule should be extended. There are scientific reasons why there are fascinating questions that can be asked about embryos developing beyond that stage. But I think at that stage we are then starting to enter into something that begins to, it's not just a bundle of cells. You might argue that the 1, 2, 4, 8, 16 cells, it's just a bundle of cells. There's nothing, no physical characteristics about it that make it even remotely like any organism. But once you get to the 14-day limit, there are characteristics then that start to emerge. So I would want to hold very tightly to that 14-day rule. But there are pressures from many scientists who say that, no, we should allow it to develop beyond that. Mm-hmm. I can't say what the rules are in North America. You may know better than me.
Right. There's a phrase I like: just because you can do something doesn't mean you should do something.
Absolutely. I mean, I think that's an ethical question that goes right across science, not just in genome editing. There are lots of fascinating questions that I would love to ask, but you just shouldn't do it. Mm-hmm. Let me give you a crazy example. We know the Neanderthal genome. And so in theory, we could reconstruct the Neanderthal genome and we could modify an embryo so that it contained not a human genome, but a Neanderthal one. It's a bit of science fiction. Should we then be able to, I'd be fascinated to know what a Neanderthal was like. We'd have to implant that modified embryo in a normal human being. And it would be fascinating, but we just must not do that because we're raising something, an organism, which will be sentient and not that far different from us as Homo sapiens. Just to satisfy scientific curiosity, to make what might be called zoo animals almost. And that's just maybe a silly example of where I think it would be a fascinating question to ask, but we mustn't do it. Mm-hmm. And I'm sure you can think of other ones as well. What would a human chimpanzee hybrid look like? Mm-hmm. Fascinating, but we mustn't do it.
Right.
So is there a safe way to move forward? Because I can imagine, like a parent, if they know their child is going to have some disability, even if it's not like a severe disability, but maybe it prevents them from being employed, right, or something like that, because they just can't handle stuff. I can imagine a parent wanting to sort of, correct that. So, and I would imagine a future where there will be a lot of pressure for that too. So how can you imagine a safe way forward?
I think it's something that going to have to be argued over by, I think, a mixture of people. I don't think it's for the scientists or even the ethicists to make this decision, or even the lawyers and the politicians. I think this is something that has such great social consequences. It needs agreement across professions, across different abilities as to what should and shouldn't be allowed. I think you're right. There will be pressures. Modifying a child postpartum, so something that's been is an infant. I don't think that has quite so many ethical questions in it. Risk is always going to be a question as to what if you modify by accident another part of the genome. And the scientific literature seems to be quite, there's no consensus over that. There are some who say, well, this technology gives very, very high successes and very few failures. Whereas there are others who say, well, when they look at the sequence of the human genome that's been modified, there are all kinds of damaging events that occurred in other places as well. There's no doubt the technology is improving as we get to know more about the enzymes that enable that, so make them more and more specific. So some of those questions of risk will start to go away. After all, risk is an integral part of being human. Every time a child is born, there is risk. Pregnancy is a risky business. So we will never be able to do away without risk, nor should we. But what is justifiable risk? What are the things that we should say that we would allow to be modified? And I think we almost need a long, long list of them that have been talked about by Christians particularly, but those of all kinds of backgrounds, so we reach a consensus. So cystic fibrosis, for instance, it's fairly debilitating. Hemophilia. There are then other, maybe rarer diseases that mean the child will only live maybe sometimes for a few months. And some of those have tragic consequences that are sometimes played out in the media, which I really wish we didn't have to do. These are very personal things. When a child is born with a genetic condition that means they won't live long, and how long should intervention by the medics continue? And should we modify those genes in embryos before they're born? And to my mind, I think that is perfectly allowable. It's preventing considerable suffering. It's giving life where there otherwise wouldn't have been. But whereas there's no simple boundary, if you like, between one and the other, it's a whole spectrum. And it almost comes down to the individual, or it comes down, I think, to, the groups of people agreeing together as we as humans say, this is what should be allowed and this is what shouldn't. Very, very difficult.
A couple of things, Keith. One is just to plug your book. I just checked on Amazon Canada. It's $8.80. So jump on Amazon, anyone, download it. Paperback price is same as the Kindle price, interestingly. That little detail aside, so I mean, you've worked through these issues for yourself. You've published on it, and I'm thinking the ethics side here again. So you've had a chance to form some fairly clear ideas for yourself. What are the questions that you're still feeling a bit unclear yourself? Are there areas where you're still trying to work through the ethics for yourself?
Yes, I mean, it reflects back really on the previous sort of question. It is actually deciding at that boundary what is allowable and what's not. Mm-hmm. I mean, in my view, the genetic enhancements by this sort of gene modification for giving better athletic prowess, if we could ever do it for increasing intelligence, those sorts of things should always be no-nos. We don't do them. Mm-hmm. For modifying for debilitating diseases, I think we should permit that to happen. But I personally struggle to work out just what do we do in that middle ground, where there will be some form of genetic disability, maybe not life-threatening, maybe life-changing, and what that, as I tried to say, what that means for the way in which society treats those people. I mean, an example would be, say, Down syndrome, for which the incidence of that is decreasing in the Western world because of increased diagnosis at an early stage and leading through to abortion. And yet we know that Down's children may be different, but they're still human beings, and they have very lovable characters with realistic lifespans. So that's an instance, I think, where we see people who are different from maybe what we might call normal. But that says more about our prejudice as to what's normal. And we want everybody in society to be like us, with our sorts of intelligence, our sorts of physical abilities, our sorts of emotional skills. And we are just reinforcing that. And that's maybe an extreme example, but there are plenty of others, I think, where we could start to say, well, I want everybody to look like me. And I want everybody to behave like me. And the Christian particularly can say that each one of us is different. And
I was intrigued
not that you're not all like me. Sorry.
I was intrigued by your earlier comments. Can we modify for morality? So is it immoral to modify our genes for moral improvement? There's a certain paradoxical irony there. So, I mean, can we modify for greater compassion?
Eventually, maybe we could, but I don't think we should.
Right.
That's part of the whole business of love and acceptance and grace, isn't it? It is that we live and we work with the genes that we've got, and that sometimes we fight against them so that we choose to be virtuous. Right? Some of us might find it harder to make that choice, but God didn't make us as automatons who could only just do good things. We were made with choice as to whether we lived according to his way or we don't. And that's free will in that, and there's love in that as well. And I think we start to lose that should we be modifying humans so that they might be more virtuous.
Question. Among your conversation with modification, are there many conversation about gender? So about LGBTQ, like they would afterwards they'll talk about, oh, I was born this way, but I'm supposed to be that way. Would there be conversation, oh, I should just change or the gene early on, so then I don't have to do or whatever the society thinks, yes, gender need to change later on?
Yes, I think, that is a difficult question, but I think as far as we are aware, there is no gene for LGBTQ. There are a whole variety of different social, maybe some genetic influences, but we don't really know what predisposes people to be one way or another. That those who are, say, transgender, who say that no, they're in the wrong body, that there is no genetic, if you like, link to that. If there was one, I feel we again, those modifications would have to be made at the embryo. And again, I think then at that stage, you are starting asking questions about autonomy, where the fetus is not choosing, has no say in the way that they're modified to be different, to be a different gender, or to grow up to think they're a different gender. Mm. I think, there are already in parts of the world, not through genome modification, but embryo selection for one gender or another. In many countries, it is seen to be better to have male children than female. And the rate at which, if you look at the births of men, boys and girls, in some countries, there is a difference between those two. I have no evidence for it whatsoever, but there have been a few instances of celebrity couples having children by IVF. And in almost every instance, it's one boy and one girl. and I wonder if that's a coincidence or just they choose a nice family, will have one boy and one girl. So I think sex selection probably occurs already, irrespective of any form of genetic enhancement. It shouldn't do. What we would do if we did understand a little bit more about the genetic drivers that influence the whole LGBTQ debate. I think that's a question I don't want to go down that line because I don't think we know enough at the moment. Thank you. It's a real question.
I do have a kind of last, maybe this will be the last question. It's slightly off the topic maybe, but I just heard a talk recently about modifying bacteria for climate change and for food supplies. How would that connect to this conversation of the how ethical or risks and things like that?
Yeah, it is a slightly different question, but the same techniques can be used for modifying bacteria, viruses, you name it. They're powerful. It's different from the classic GM debates where we've been taking a gene out of one organism, a plant, or sort of an animal, and putting it in a plant. This is a technology often for just shuffling genes, as I say, between things. So there's less of an uproar against the genetic modification. I think if we have the technology to improve crops and those sorts of things, and if they're shown to be safe, and there have to be plenty of tests to be sure of that. And no, the rigor in which that's done is extreme at the moment. I think it is, if you like, a moral imperative that we should do it. If it comes to modifying animals, I think we need to start asking other questions as to whether it starts to cause some form of suffering in those animals. So we're increasing muscle mass in some particular place so that we get, better quality beef, but the particular cattle have really low quality lives. And we've seen it in some instances where they can't move properly, they can't breathe properly, but they produce better quality, more efficient meat for us. Then those are the sorts of modifications that we should say no to. But if it's not causing suffering and it increases the food supply, especially in places where it's very limited, then I think we should seriously consider using this technology and others for the benefit of mankind. And that is one way in which I think science is a gift from God, and where we are told to subdue the world, to look after it, to keep the garden looking nice. And I think science is one way in which we are privileged to be able to play our part in that. So that is a very different question, but I think it's a really, very, very important one that needs a different talk altogether.
Yeah. All right, cool. So thank you very much, Keith, and thank you for everybody.